Hi, have you ever encountered a situation when your application crashes or gets totally unresponsive after some time when user interacts with it? If yes, then most probably your application has got a huge memory leak that causes these issues. And in this lesson, I'm going to share with you some debugging techniques that will help you to find memory leaks in your applications and then eventually, hopefully, fix them. If it is your first time on my channel, my name is Dmitry Mrzhensky and I help people to become advanced Angular and web developers. You can check out my YouTube channel later, but now let's learn how to debug memory leaks in your web applications. Before we start debugging, let's learn some theory about memory management in JavaScript. Let's learn what are actually memory leaks and how they might happen in our applications. In short, a memory leak, this is when your program retains memory that it no longer needs. But how can it happen in JavaScript where memory management happens automatically? To understand it, we have to take a closer look at this process. Imagine your application consists of one single function that has some variables with assigned values. When the program runs, those values have to be stored somewhere. And this somewhere is actually the device memory that we can visually represent as a group of cells or boxes. So our program has to reserve some of those boxes for storing variable values, which is known as a memory allocation. Once the program is executed, the values remain in memory, although they are not needed anymore. So someone has to kick them out of the memory, and this someone is the JavaScript garbage collector. Its responsibility is to simply check if anybody else references this memory cell, and if not, just release it from memory, just remove those values. And in such a way, all memory allocated by the program is released and no memory leak happens. However, sometimes, intentionally or not, but we can introduce implicit retainers that continue referencing some values in the memory even though we don't need them anymore. For example, we can simply remove or forget about the let declaration, which is actually the same as making it a property of the global window object. In this case, once the program is executed, the garbage collector will not be able to release it from memory because the window property lives even after the program is finished, keeping the reference to this value in memory. And this is exactly a memory leak, meaning that our application allocated more memory than was eventually released. Unintentional and unhandled global variables, this is only one way to introduce memory leaks in your applications. But JavaScript offers you many other options to shoot yourself in the foot. For example, it might be unreleased timers, it might be uncleared event handler for the DOM element that has been removed, or it might be a closure that continue referencing some other objects that are no longer needed. And despite memory leaks can lead to application crashing and general performance degradation, not all of them are so dangerous. Memory leaks can be pretty static ones. It means that it doesn't matter how many times you execute your program, the size of the memory leak remains the same. But also they might be dynamic ones and allocate more and more memory every time you execute your program. In most cases, exactly this type of memory leaks is causing our application crash, and exactly these type of leaks we have to fix in first place. And now let's see how to detect this kind of memory leaks. But before we dive into the debugging process, I would like to share with you two best practices that can make your measurements more accurate. First, always debug your application in the incognito browser window. In such a way, you can be sure that none of the browser extensions impact your measurements. Secondly, always debug the production build of your application, because most frameworks in development mode, they perform different actions under the hood that might also impact your measurements. In my example, I will be using an Angular application, and production build can be achieved by simply running the npm run build command. However, what I would also recommend you to do is to add an environment variable ng-build mangle and set it to false, and place this environment variable in front of the build command. This will prevent the variable and class name shortening while keeping all other production optimizations in place. And this will make it easier to understand the compiled code while you debug your application. And then you can simply use some lightweight HTTP server to serve artifacts we just built. So here is my application, and I reused the one from my previous video about dynamic components in Angular, which you can, by the way, also check out later if you want. And the only thing this application does, it creates a certain widget component along with some projected content, and also it allows me to destroy this widget component. And of course, I slightly modified this application and introduced a few memory leaks that we will try to find. First approach to detect if our memory is leaking is to use the performance tab, which might give you a general overview of how memory is allocated. So let's tick the memory checkbox here and trigger the garbage collector manually to make sure that everything that could be released from the memory is actually released. And after that, let's start profiling our application. And now we have to start interacting with the app. The idea is that you perform a certain little repetitive actions like creating a component, and then you immediately revert your application back to the previous state by destroying this created component. Theoretically, the memory allocated for the dynamically created component is supposed to be released once we destroy it. So if I repeat this action multiple times in a row, we should not see memory consumption increasing, but it's in theory. So let's trigger garbage collector once again and stop profiling and see what result we will get. So here, make sure that you tick the GS Heap checkbox, and you should see something similar to what I have. This blue line shows memory consumption by our application over time. And you can see how memory allocation increases, and at some point it might drop, which is actually the result of the garbage collector's work that releases memory automatically. However, you can see that despite the garbage collector working, the memory allocation constantly increases, and a pattern like this is the first indicator that your application probably has a memory leak. But don't freak out just yet. As I said, not every memory leak is dangerous, so always look at how much memory was allocated at the beginning when you started profiling and in the end. Sometimes it might be just a few kilobytes, which might be acceptable, but in my case the difference is about a few megabytes, which is quite a lot for such a small application that I have. So in my case, it makes sense to dig deeper into what's going on there. To get more insights about the allocated memory, we should switch to the Memory tab. This one offers a lot of great tools to inspect the memory consumption in depth. Firstly, I will show you some of them in action, and then we will learn how to use them for the memory leak detection. For example, you can take a memory snapshot that records everything that is currently allocated in memory at this point. And you can see here stuff like functions, strings, HTML elements, like everything is here. You can even find instances of your component classes if you try to use the corresponding search field. And despite this view is very insightful, unfortunately it doesn't tell you when exactly each of these objects is created. But if you want to know at which point objects are created, you can use another tool called Allocations on Timeline. This tool tracks and records memory allocations in real time while you are interacting with your application. So if I start interacting with my app, you can see a heap on the timeline that indicates how much memory is allocated for each of my actions. So I can create and remove my component multiple times, and yeah, then let's stop the recording. And now I can focus on each of these actions by clicking on this spike and see what objects were created or allocated exactly at the point when I created my component. And don't be surprised that the first interaction allocated significantly more memory compared to my same actions. This is because the first time Angular creates different stuff like a view container, which will be eventually reused when I create a dynamic component next time. But anyway, the same way I can look at what objects were created in memory when I remove the component, and I continue to do so for all my actions. But how we can use this tool and the information it provides in order to catch a memory leak? Well, what I sometimes like to do is to drag the selection of the timeline and see how the amount of allocated objects that are potentially related to my code changes. Usually those leaking objects, they are popping up as long as you drag your timeline because their accumulated retained size grows accordingly. For example, you can see that increases number of the save subscriber object instances, and this amount reflects the number of times I created the component, which looks weird, right? The same thing you can see for the consumer observer, the object with next error and complete properties. And what is even more strange is that we have multiple instances of the weather content component, though all of them are supposed to be removed because we don't have a corresponding component rendered on the page right now. You can also use the class name filter to focus on some particular object and see how the number of instances dynamically changes over the time. So this is something I can already work with, and this is the second confirmation that my application most probably leaking. Now, how we can figure out who is referencing this object and prevents it from being garbage collected. For that, you have to click on the certain object instance and pull up the tab called Retainers that you can find here below. This tab contains a final retainer that gives a reference to this object. So if you expand it, you can see the entire chain of references that leads to the final retainer. From here, you can learn that this retainer being referenced in the context of some function, arrow function, and this arrow function is referenced by the next property of the following object, which is referenced by a partial observer in the consumer observer class instance, and so on. Usually you don't have to go in depth into this entire chain, and what you usually need is one of the first references that has a link to your code bundle, which eventually brings you to the part of the code that created that reference. In my case, you can see that this is a long-living RxJS subscription that was not handled properly and keeps referencing to the weather content component class instance via the this keyword and prevents it from being garbage collected. Classical example in Angular. Alternatively, you could come to the same point by comparing the memory heap snapshots as well, and how to do that I will show you right now. And while I switch to this tool, please consider subscribe to my channel if you enjoyed this video, and let me know if my efforts were not useless by hit like to this video, if you like, of course. I would highly appreciate it. So, how we can catch a memory leak with the memory heap snapshots? First, make sure that you select it here and then reload the page. Now click this button to make an initial memory snapshot of your application, and then we have to perform a certain action that you think might cause a memory leak, like creating and destroying a component multiple times. And after that, you have to create another snapshot. And after that, you can use special filters and comparison tools to find suspicious deviations. For example, you can select an option that will show you what objects are created between those two snapshots. From here, you can look for the stuff that is related to your code and looks strange somehow. For example, again, you can see multiple instances of the save subscriber objects as well as the weather content component instance, right? And so on. Or you can use the comparison tool and compare these second snapshots with the first one. From this view, you can learn how many objects were created, deleted, and delta. And delta represents the difference between the created and deleted objects. And a positive delta might point to a potential memory leak. So if you have a look at the delta here, you can see again that the save subscriber instance stands out, as well as the weather content component, and the entire group of objects, delta of which ones is the same and matches the amount of component creations I performed between those two snapshots, which is very, very suspicious, isn't it? By the way, talking about two snapshots, in reality, it might not be immediately obvious that this is a memory leak. So what I would recommend is to create at least one more snapshot and check if you can see a similar pattern for the similar objects. So let's again try to multiple times create and destroy our component. And let's create a new snapshot and compare it against the second one. And you can see again the increased delta of the same objects. This is the weather content component, those are subscribers and others. So now we can certainly declare that we have a deal with the memory leak. And how to find the retainer, you already know. Just select the object that you think is leaking, and in the retainer's view you can find a link to the code which causes a problem. So in my case, the solution would be applying a special operator like take until destroyed that will kill the subscription whenever the corresponding component is destroyed, but you can use any other strategy to handle long-living subscriptions. Just choose whatever you like. So now we can rebuild our application and inspect the memory allocation once again to make sure that we fixed the problem, right? So let me reload the app. I'm going to create the initial snapshot. Then let's create and destroy our weather component multiple times. And after that, let's take another snapshot. And now if you try to compare those two and try to find an instance of, for example, save subscriber, you can see that it doesn't exist anymore in the memory, and the same result will be for the class instance of the weather content component, because it was garbage collected and removed from the memory as we expected. However, your eye could catch this detached element that looks like related thing to our widget component instance. This is another type of memory leaks that you can encounter in your web applications, which a lot of Angular developers don't even think about focusing on the leaks caused by unhandled RxJS subscriptions. How to debug and fix this kind of memory leaks, I will show you in the second part of this video that I'm going to publish in the next couple of weeks. So if you don't want to miss this video, consider subscribing to my channel right now and enable all notifications. If you want to see this video earlier, you can always become a channel member and get access to upcoming videos much earlier, and also you can enjoy some exclusive and in-depth Angular content. If you want to discuss this or any other Angular topic or get connected with other developers around the world, join our Angular Discord community. It is free and open for everyone. For those who want to level up Angular skills as soon as possible, I packed all my experience into a series of video courses that will help you to master such advanced Angular topics like Angular forms, unit testing, and many others. They will definitely help you to stand out among others and be a better Angular developer. Links will be in the video description. Otherwise, thanks for watching this video until the end. Please share this video if you like it, and I wish you a productive week ahead. Stay safe and see you in the next video.